based. If there's any question at any time, please feel free to go ahead and type your question or go ahead and unmute your mic. That way we can have a conversation and go ahead and resolve any questions by any means that we could. I am Shivani Wyas. I'm Technical Services Engineer with Odessa Separators. I've been here for about 3 years, and so I've had hands-on on designing and researching on the data and just trying to see how to optimize the downhole tools. And just a little bit idea about Odessa Separators. We do have, just like the oil and gas industry, we do have our footsteps all around, but at the same time, we're pretty tight-knit. We're here locally based, headquarters in the Permian Basin, manufacture here, and that's where we have all our R&D and engineering team, as well as another international office in Colombia. And most of the application is on all kinds of artificial lift system, either the ESPs, rod, PCPs, gas lifts. But today we're going to concentrate on sucker rod pumps and try and see what we can do to optimize that production, especially on a discipline that we go ahead and concentrate. It's going to be chemical treatment. So since we have all the wells shut in, we do know what's happening in the Permian Basin. That chemical treatment in the well itself. And what we use is we call the microencapsulation technology. So to go ahead and give you an example is what is used in the medical field. As probably a few years back, we're used to having that liquid form of medicine. So you have your syrup probably 3 times a day. And now you have that one tablet, have it once a day, and it slowly releases it. And that's exactly what is microencapsulation, is that foam is encapsulated in that tab, that way it slowly releases out. And that's what we do in the chemicals as well, is we go ahead and microencapsulate the same surface liquids that is going to be used in the wells, but we go ahead and pressurize it and have it in the solid form. That way it slowly releases in a way that it lasts however long it needs to be and gets treated exactly where it needs to be treated. So that's where you can see is basically we have our chemical product, the surface chemical product that we were talking about, liquid, and it goes ahead and forms into a matrix, which is probably going to be your water-soluble matrix, gets blended, pressurized, and gets into your solid form, and gets pressurized again and comes out in the form of sticks. And that sticks are going to go ahead and get into your chemical screens. So the conventional way of the industry of chemical treating is from the surface. It's from top to the bottom. Versus what we want to go ahead and intend is going to go ahead and treat from bottom to the top. So what this chemical is going to do is going to go ahead and replace the last part of your BHA or your bull plug. That way, with wells with such high fluid levels, we're going to go ahead and treat downhole and treat the fluid before it goes to your pump. That way, all the fluid is treated before it goes ahead and goes into the artificial lift system. And then depending on what kind of problems do we have, if it's paraffin, if it's scale, if it's iron sulfide, corrosion, whatever it is we can go ahead and combine, depending on the CWA test, the complete water analysis test that we do, combine it and have that full chemical screen made up. That way the pH of the water is balanced. And so this is just trying to go ahead and show us what the microencapsulation technology is, like we talked before, is water-soluble matrix, and depending on the bottom hole temperatures and pressures, this would vary. So what happens is what we have in Permian Basin, the matrix is going to differ what we have in North Dakota or Bakken because of that bottom hole temperatures as well as the water cut percentage, which is pretty common here as about 70 to 80% of water cut. Or let's say internationally in Colombia, it's going to be way different than what we have here. So that is going to make a huge difference because that's what's going to go ahead and disperse your chemicals and dissipate in the fluid depending on how it interacts with your fluids. And that's what it is it goes ahead and this matrix that it's formed is then when goes ahead and goes into the chemical screens itself. So once it is placed here in the chemical screens, let's see how does it disperse out. So let's go ahead and rewind. This is going to be the last part of your BHA. So it goes and has at the very bottom below your tailpipes or your mud joints and replaces the bull plug, right? So as soon as your fluid gets in contact with this dispersion area, that's where the chemical leaches out. In other terms, it's just like a tea bag effect. As soon as you have that tea bag in the fluid, your tea disperses out. Same thing, as soon as your fluid comes in contact with the dispersion area, right here, that's where the chemical leaches out, and everything that is going to go up in the artificial lift system is treated before it goes into the pump and produces it. That's what it's showing is the dispersion, and then it goes upward. And then depending on, obviously, what is the production, if we're talking about gas lifts or we're talking about ESPs, sucker rod pumps, the production is going to significantly vary from the ranges. And that's how we're going to go ahead and size it up is what is the size of the chemical screens that we need. Everyone comes in a 24-foot section, and depending on the runtime that we're targeting, if it's a year and a half, or probably months before we're going to go ahead and pull the well, it depends on the length of the chemical screens. And then there's something that's called quick release, is we have a problem well, and we do know that this one needs something of a THPS or iron sulfide that's built up, and as soon as you have it installed on the BHA, it needs to go ahead and treat it out. That's where we use the quick release to go ahead and releases it up in about a few days and treats the well pretty quick. And then obviously the inhibitors, depending on the CWAs that we have, defoamers, that's what is pretty common in the Midland Basin. It forms a lot of foam in the fluid, and that's what, in our experience, we've had a great success is using defoamers along with that gas separation, and then scale or scavenger corrosion. That would all vary on the complete water analysis. Also, one of the things on the technology that we found useful is whenever we're pulling the wells, and what happens is once you have your BHA pulled, what happens is as soon as you have that torque and pull up your cam screens, sometimes what would happen is you have that chemical solid sticks go ahead and leach out on location. So to go ahead and prevent that, one of the technologies or techniques that we've gone ahead and installed in it is a shutoff valve. So as soon as you have that pressure, the valve goes ahead and activates itself. That way, let's say you're going ahead and have a well intervention and want to have the same cam screen, since it has some chemicals left, installed it in the well valve activates, and you're not going to go ahead and have that chemicals go ahead and disperse out on the location and waste those chemicals. And that's what we have on the valves, and it activates on the pressures. Another thing that goes ahead and comes into play is what if we don't want to pull the tubing? So that's something that we have the retrievable cam screen or the retrievable cam tool that could last up to 6 months, where you would just have to go via slick line and we'd have to go ahead and plan initially if, let's say, we want to go ahead and have this treatment for about a year, and after that go ahead and have that slick line joined with about 60 foot or 30 foot, whatever is that we need. We can go ahead and go through the slick line without pulling the tubing. That's what is called the retrievable cam tool, which comes in 1 inch, 1.25 inches, 1.5 inches, and could be done by that. And so again, that's what it has is what is the scale-rich inhibitors, or what is acid sulfoctant inhibitors. So what we have is acid sulfoctant. It always has to be a combination if there's already scale built up, and we have to go ahead and take care of that built up scale. That's where we go ahead and use that acid sulfoctant to dissolve the scale, as well as that scale-rich inhibitors would be something that would be used if we want to prevent the formation of the scale. So that's something that always comes into play. It's so critical that with the fluid, there's always going to be difference of the pH, or there's always some chemistry that's changing. So to have that balance of dissolving as well as prevention of forming that scale again is that's what forms the scale inhibitors. And then corrosion as well is going to be something that is going to be mixture of coco quad that is that goes ahead and has that deformation of that corrosion, as well as triazine based scavenger that's going to go ahead and have for high of that acid gas, the CO2, H2S, that usually forms or corrodes the tubing or the equipment in the well. And then that's also the combination of what we have on paraffin is depending on what we have on the dispersion or the soap stick technology that the industry's used to for dissolving paraffin is just concentrated in such a way that you can have it in the long term. And this is what it says. It has 78% of that active level of that soap stick or paraffin stick that's used. And basically showing some of the standard, what we've learned from our experience around in the Permian Basin. What works well is if we need 100% scale that has a CD number assigned to it. So if we know definitely that this well has too much scale and we just want to go ahead and treat it for scale, downhole and on the surface, let's say it's been treated for corrosion, that way it goes ahead and takes care of just one particular problem. That's what it has. It's 100% scale, has a CD number assigned to it, and then that's what it goes down the list is the combination of scale, corrosion. You have combination of acid sulfoctant and scale. You have paraffin and scale. So everything that could be combined is going to go ahead and has a CD number assigned to it. And something that if our lab or if our chemist or engineering team goes ahead and does an analysis on the CWA and says this is something that we need a special combination, it's not a standard, it's not a problem, go ahead and since we manufacture, we can go ahead and say, okay, this needs probably this much percentage of a combination of scale, corrosion, THPS, which is a huge problem these days around in the Martin, Howard County, that we're forming iron sulfide. So that's something that we've gone ahead and say, let's go ahead and add this, even though it's not something that's been standard on the CD numbers. But one of the examples that it's really interesting to go ahead and portray is we can see the efficiency of the chemical screens before and after the chemical treatment itself. So we can see on the left-hand side is during a pull, and this is on ESP, but we can just, this is an example to show how effective is the chemical treatment. So we can see while the rig is pulling this equipment before the OSI installment, we can see how much scale is coming out of this tubing. Chunks and chunks of scale. And that's what it has, that this had about 1,000 barrels of fluid of production and about 80% of water cut. And the same well that had the chemical treatment for a downhole when we're pulling. You can access, yes. That's what it was, and that's what we're going to go ahead and talk about some of the case studies, because that's where it's important to go ahead and say, when we're treating downhole, what are the analysis that we do to say, A, it's working, B, it's down there, because how do I know that once we go ahead and install the downhole chemicals? Before we go ahead and show the analysis, let me go ahead and explain how do we know that the chemical, once it's installed, is still down there. So what differentiates OSI's chemicals than any other chemical is by a special test that's called a polytag test, which means with X amount of chemicals, we would have certain amount of polymer dispersed in the chemical itself. So whenever that chemical disperses out in the fluid, you can go ahead and have that fluid up in the lab. We can perform the polytag test and say, okay, this is the ppm of that polymer in the fluid, which means that the chemical is still dispersing out and it's still out there working. That is just a detection of that chemical is still down there. B is we're going to go ahead and do other tests or give it out in the third-party lab. That way we have if that components that form the scale, corrosion, iron sulfide, what is it in the water? Has it been there? Has it decreased? How efficient has the chemicals been downhole? And since it's third-party lab, it's something that we're not done. It's verified from some other lab that says that if this is working or not. And 3 is the runtime. Again, the polytag is going to go ahead and give us that runtime. If we're taking the fluid test every month, let's say we've planned this as that ppm or the polytag residual has been there consistent for a year, how long has it been than what we've targeted. So all these things would come in after the installation. It's not just stopped once it's installed, it's what has it helped to optimize that production or the fluids in the well itself. So some of the case studies that we're going to see, this one is on a rod pump, and this is, I believe, in Martin County. Had severe scale and corrosion issues, and production and average production, what we can see is about 100 barrels of fluid per day, and or 100 to 150 barrels of fluid per day. And then we did the complete water analysis, had the simulation done on it, and did identify that it had some type of scale precipitation. So we had about just a 24-foot of treatment with scale that we had scale and corrosion, 50 scale, 50 corrosion for this one. So we can see the wellbore schematic. We would have to have an intake for the fluids before it gets treated and goes into the pump, and that's what it has, the 2 7/8, the dispersion area that the chemical disperses out, goes into the intake, into the pump, and It says it's been installed in 5/8/2019, and some of the samples that were determined to go ahead and see if this chemical is working or not is iron, manganese, THPS, polytag, and that's what we're going to see is right here. The iron and manganese is what goes ahead and shows us how effective is that corrosion inhibitor being down there. So anywhere that we can see here, we can see right in the beginning. So the blue is the iron. Before it was installed, we can see how high it is to how low it's gone over the period of the time. And for manganese, its optimal rate is, if it is about 1 MPY, that's where it's called the optimal rate, and that's what we have. We can see over the period of time. That is a confirmation that your corrosion inhibitor is working, and so is the same thing for manganese. We can see that over the period of time. It's been pretty stable. And then down below, we have the scale and corrosion inhibitor, and this is what it shows is the MIC, is the minimum concentration line. That's where we have is how much of that concentration of inhibitor is still there in the fluid test that we're done. So that's what also shows us the longevity, and that's where it shows it's been run for 337 days, that 24 foot of chemical joint. And then again, the THPS and polytag, like I mentioned, polytag is something that we would say just to go ahead and see how much is that polymer or the chemical dispersed out and still there. So see right here, we have this line that says this is the minimum polytag concentration that we need to have. And once we hit that, that's when we know, okay, the chemical is dispersed out. Either we need to go ahead and pull the tubing, or we can go ahead and have that retrievable cam tool so that we don't have to pull the tubing, or if there's surface treatment that the operator would want to do, we can go ahead and do that. Also, another thing that we need to really notice here is the corrosion rate. So before we went ahead and installed, we can see this is where the corrosion rate is, right? It went down, that's where it is. Every month we go ahead and do the analysis. And the month that we had that polytag test, that means it's completely out, we have that corrosion rate go up high. So which means that the chemical or confirmation that it was working, and as soon as it dispersed out, we have that corrosion rate high up. And this is something that is measured by the coupons that is installed in the surface, and this is given to a third-party lab, and that's where we have the lab results. So this is a confirmation by the third party as well that, okay, if it's working, not working. Another case study, this would be in Martin County. Again, had a lot of scale and corrosion issues, and about a production of 200 barrels of fluid per day. And we can see right here is we have two sections, top and bottom, just for the 48 foot, a combination of scale and corrosion. And in this one, we did find siderite. So that's where we were like, okay, we need something that goes ahead and dissolves the already formed scale. So that's why we have seen that we've used that acid sulfoctane as well on that combination. We can see the iron manganese again. On this one, the blue is going to be your iron and the orange is going to be the manganese, and we can see how much stable it's been. Also, over here, we can see that the manganese is increased, and that's what, I was just questioning that and got to find out that since in the past month, all the wells have been shut in, most of the wells have been shut in. That's where we have that increase either in the fluid level or just because that water is stable, that can go ahead and now have so much effect on the chemistry itself. So that's where the manganese has also increased. But overall, we can again see how the scale and corrosion inhibitor has gone ahead and had that runtime we've done for 280 days, and it's still running. So that's something that goes ahead and again confronts that what are the components that it's affecting, how much is the scale and corrosion downhole that's still working. And obviously the DHPS and polytag are on our lab that's done and said if the chemical is there, or if the DHPS concentration that is again for iron sulfide is been there in the fluid samples that we get. And then that's the corrosion rate. Again, as long as it's below 1 MPY, and we can see whenever we started it, it was 0.6, where it's been successfully drawn down to less than 0.2 or at 0.2, and which means that it's been extremely effective. Again, this is from the surface or the coupon that's tested in the third-party lab. We get the results, and that's what we go ahead and have that on the result test as well. Now, this one is similar case, similar in the Martin Howard area, again with scale and corrosion issues, but we can see the production has been pretty much, it's has its gaps, and it did have, I believe it was about 50 to 100 barrels of fluid per day. That's what it was designed for. And we can see it had 50 scale, 50 corrosion, and this one is the one that had 2 installations for chemicals. So that's why we can see the first run was installed in December of 2018, and that's where we have the results that since December to December, it's a 1-year runtime with that 24-foot of chemical screen. So installed in December 2018, pulled in December 2019, and we can see this one is tremendous on the results of iron, where we started, and by the time, how much were we able to reduce that iron, as well as manganese has been pretty stable and has been able to be reduced as well. And also the scale and corrosion inhibitor, that's where it goes ahead and shows the longevity, and that's right here we know that, okay, we've hit the rock bottom and we have to go ahead and let's see what else can we do. And that's where we have right here, it has 350 days of runtime with that 24-foot of the chem screen, had an intervention, pulled the well, and that's where also goes ahead and shows how much of the corrosion rate. So now this one is another installation. So since December to December, we had about a year's runtime, and I believe after that is we went ahead and had installation on the same well. So my bad, that should be on the other well, but that's what it shows that, that when iron sulfide was pulled on this well, that's where we had the configuration or the difference in the chemical combination. Yes, it's on the same well as well. So in December to 2019, we pulled it, and since we had that, this has iron sulfide on the next installation, we went ahead with 48-foot, and we had that 60% of THPS, which means it's treating iron sulfide. It has scale and corrosion, and then again, combination scale, corrosion, and THPS. And that's what we can see. The 2 installations, the runtime, how much is the iron manganese, as well as since it's been installed from March of this year, and it's still running, and seeing the components as well as the same thing. We had the concentration of the inhibitors go down. The operator decided to go ahead and pull the tubing, and we went ahead and analyzed and saw that it has some iron sulfide, had change in the combination, had change in the length, and went ahead and are still doing, and it's still running. And so still now it's 104 days after the 350 days of the runtime and the second pull or the second installation. And that's what we have. That's where we can see in the second run too, we can see how high, since this is the frame that the well wasn't running or operating, and we can see how high the corrosion rate had gone there, and we're successfully able to reduce the corrosion rate below 1 MPY, which is again a confirmation that, okay, it's running and it's running successfully. We're going to go ahead and do 2 more short case studies, pretty short, just to go ahead and see. So this well, we can see is on rod pump. We can see every red line is the intervention that they've had. So we can see the run life. RL goes ahead and shows the run life, which is first is 106 days. It's 98 days, 117 days, and then the well is inactive. After that, we had the OSI chemical combination, and right here we can also see on the left, whenever we had that pooling, you can see how much of high scale presence is in the well, and that's what caused that intervention of that well. Every single time we can see it's scale, scale, scale. And so whenever we went ahead and had the installation first time, 161 days, highest than all the days, and it was pulled because of a rod part, then install it again and it's 295 days. Also, another thing that is noticeable here is we can see the fluid level above the pump, every single one here. We can see how high it is, versus once we have the chemical screens downhole, which means that it's going to go ahead and reduce that fluid level, and the pump is actually pumping and producing. Also confirmation. One more thing is the SPM. We can see before it was pretty high, and how low, about 3.5 to 4, or before it was about, we can see 6.5 to 7. And even though they slowed the pump, it was able to reduce the fluid level and has been given good runtime. One last case study is we can see is about paraffin. So on the pulling reports, we can see how on the plunger they have a high amount of paraffin in here. And right before that, we had runtime of about 50 days or 10 days. We have 96 days, 10 days again. And we went ahead and had that chemical combination. It says CD3000, which is for paraffin on scale. And once we did have that, we can see the runtime, as well as there's that phosphate tracking. That way it does show how much of the ppms do we have left and what has been the runtime, about 400 days of runtime compared to the 90-day or 10-day. That's what it is, you know, once we have the chemical installed, or even before install, it's the team that goes ahead and takes the measurements of complete water analysis that we need to know, or what is the intervention rate of that well. Once it's done and a chemical formulation is suggested, there's always an effort to go ahead and take that samples, probably a month, just to see how effective it is, how much of a runtime it is, because we all know right now we're in an economical bind, and it always does make a difference of not only if it's effective, if it's worth what you're spending, and that's what it just goes ahead and not only saves the intervention cost, but also goes ahead and proves whatever expenditures we've done is worth it or not. Yeah, that's about it. If y'all have any questions, please feel free to ask, or this is my contact too. You can feel free to reach out here. Jason, do you know if there's any questions? not sure if Jason's there. Yeah, I guess that's about it, and hope you all have a great rest of your day and great rest of your week, and try and stay cool in this West Texas weather. This week's not as bad as we had last week, but enjoy the rest of your week. Thank you.
Hey, Juby,
Mm-hmm.
can you hear me?
Yeah.
Hey, Juby, good morning. Yeah, I just
Good
got
morning.
a question here. Related to the temperature, how the temperature affect the chemical release.
Mm-hmm.
So it says, Joan says, how the chemical dispersion is affected by temperature and how to achieve 365 days on high temperature wells without running a longer tool.
Okay, great question, John. So what we've experienced is that has an absolute effect, and that also comes into the play of the metrics that was explained in before on whenever we form the chemicals. So whenever we form it, it depends on what is the percentage of matrix that we have in the chemical. What used in the Permian Basin is going to be much different than what is going to go ahead and used in the Bakken. So that matrix does go ahead and vary, and that's what will go ahead and have that effect. So to answer that question, that metric percentage would be increased in that chemical dispersion. That way it is dispersed in a controlled manner, and that way it has to achieve that longer runtime that we want. Instead of going ahead and having a longer BHA, we can have the same shorter BHA, but also control that dispersion.
Thank you, Juby.
Not a problem. Thank you, Carlos, for letting me know. Well, all right. Thank you again for your time. And if there's any question or anything we can do, please feel free to reach out to any one of us or myself, and we'll be more than happy to help you all out. Thank you. Y'all have a good week.